before I give you the word, I just want to do a little introduction about yourself so that people know what your background is. Today, you're representing SAESA, the South African Energy Storage Association. You are based in South Africa, Executive Director of SAESA. But actually, this is not your only activity. You bring with you today more than 20 years experience in renewable energy. And many of the listeners today may know you as the CEO of Fibon Energy. And you've worked with different companies before this, among others, on the legal side of things with an associate of Linklaters, advising companies in energy in general, oil and gas, and financial industries. You've also been recognized as one of the future energy leaders, which is an initiative of the World Energy Council. Maybe you can tell us a little bit about this. And so I'm very pleased to welcome you today as the moderator of this session. And I will let you introduce your panelists for today.
Thank you. Thank you very much for that introduction. And good morning to our delegates that are joining us today for the second day of the Africa Solar Industry Storage Conference. I'll be moderating the panel today, and I really look forward to the session. We have a depth of expertise in thermal storage, monitoring of CNI systems, and really how hybrid systems are optimized and best performed. So with that, I'd like to introduce our panel members today. First being Rod Lancaster, who is the Business Development Director at 24/7 Solar. Rod, could you please give us some more background to yourself?
Okay, thanks very much, Avesh. I'm Australian. I'm based in Dubai. I've been here for over 10 years. And I first started working with 24/7 Solar almost 4 years ago. My role is Business Development Director. My focus is on the geographies of Australia, the Middle East, and Africa.
Thank you, Rod. And now our second panel member, Svet Baljikov, is the CEO of AMPP. Svet, please can you introduce yourself?
Thanks, Avesh. My name is Svet. I co-founded AMP a few years ago now. It's actually spinning out of Eon, where we were building and operating mini grids across Africa. We ended up developing a software platform for managing those. Spun that out into a software platform that now monitors and manages over 1,000 systems, mostly in Africa, and a large part of those are hybrid. So not just solar, but a lot of storage in those as well. And yeah, looking forward to the discussion today.
Thank you. And lastly, we have Sharif Al Shazli, who's the BD manager at NE. If you could give a bit more background as well, Sharif. Thanks.
Hey, hi guys. My name is Sharif. So I've been working with NE for the last couple of years. We develop remote battery monitoring systems, mainly targeted in the African market and predominantly with lead acid batteries. I've been working with David Smith, who is the founder of NE. We've had a long business relationship, but we've been involved in this project for it's been about 2 years since we started. And yeah, it's just been onwards and upwards. We've actually been able to secure some deals in Africa and learn a lot from some trial sites and generating kind of live data on individual battery performance. But that's kind of my role is to develop out the market in sub-Saharan Africa.
Okay, great, thank you. So with that, I'd like to keep the conversation relatively informal, and I'll be posing a series of questions, and if we could perhaps keep the same order. So Rod, Svet, and Sharif, if you could respond and to those questions in that order, it'll make it a lot easier for myself as well to manage. So first up, I think we've gotten a broader overview of what each of the companies do, but the focus of the panel today is the latest developments in storage applications, specifically in the C&I space. So with that in mind, Rod, could you perhaps talk a bit about us? Let me try that again. Can you talk to us, please, about your latest projects or initiatives? I'm quite interested to hear some more about the CSP and specifically the thermal storage applications.
Okay, thanks, Avesh. So I guess essentially this discussion panel is what is the future beyond lithium in terms of storage technology, not to replace lithium because there's so much investment in the infrastructure, but to work side by side in conjunction with lithium to address some of the challenges faced by lithium, supply, price, et cetera, with some alternate technologies. Broadly, storage and hydrogen are probably the two hottest words in the renewables industry. Today's session is focusing on the C&I, which is very much the area within the industry that 24/7 solar plays. What we bring to the discussion and to the marketplace is that 24/7 solar is the designer and manufacturer via our manufacturing partner Capstone in the US of the world's lowest cost, high temperature storage solution. It's a product that we call Heat Store. It is very high temperature. It is temperatures up to 970 centigrade, and the cost, whether we look at it from a total cost of ownership or we look at it in terms of a operating cost, kilowatt per hour, LCOE, etc., we're less than 10% of the cost of lithium. So that's the challenge that we would like to bring to the marketplace, demonstrate our technology, and become a sizable player in the niche areas where we best think that we suit, which is off-grid, which is diesel displacement, which is also microgrids. Our sweet spot is in the 1 to 20, moving to 20, moving to 50 megawatts. Thank you.
Thanks. Thank you very much, Rod. And I certainly think that the applications in the mining industry are vast with such technologies. Svet, you mentioned that you're involved in over 1,000 systems across Africa in terms of monitoring and of these systems. Could you also perhaps talk to some of your latest projects or initiatives?
Yeah, I mean, in the context of storage, as I mentioned, so pretty much all of the systems that we monitor on our platform, working with commercial and industrial system installers and operators across the continent, pretty much all of those are solar to begin with. One of the really clear trends, and I think this is the reason why we're all having this discussion here, is that more and more of these systems are now also incorporating batteries. And what's really interesting to us is to look at, well, why are batteries being installed? Now, clearly at a high level, having backup is something that's going to be very important for a lot of these systems, especially in places with less reliable power, taking something like Nigeria or South Africa, and really sort of across the continent. What gets really interesting is once you start thinking slightly beyond that. Now, again, the first point you get to maybe is when you think about optimizing your LCOE for those systems. Storage, as we all know, is still quite expensive. It's really dropping in price, and that's an important factor for take-up. But what a lot of our customers opt to do is to not just install solar plus storage. They will often also have a diesel or some other form of thermal generation there, which at the moment is still the thing that is going to lead you to the lowest, to the most optimal cost base for these systems. Now, if you take that sort of complex system where solar, you are going to have batteries that you can obviously either feed power into or out of. You're probably going to have diesel, and then of course you still have your grid connection. That really starts to open up a lot of opportunities for what you can do with those different generators and sinks. Now, across most of Africa, doing grid feed-in is still something that we're not seeing very broadly, but that is something that's becoming even more, that's slowly becoming more of a factor as regulations open up. So that's definitely one of the next things that we see. And batteries can play a very important role because you can then really optimize through batteries what power you're consuming, when you're consuming it, and then what you're potentially feeding back to the grid. That really gives you another incentive to have storage in your system. In taking that and looking at some of the more advanced cases, then we have things like peak shaving, things like load shifting, and renewable, and optimizing your renewable fraction. That's where, for us at least, is probably the most exciting place to look at. Okay, you've installed several megawatts of PV. You've got an industrial site that's using several megawatts, but obviously your PV is not going to be matched to that. How do you account for that? How do you account for maybe an intermittent grid connection? And storage really can be the answer there. And I'm not going to go into detail right now because you start getting into all these really interesting models, but that's the most exciting thing that we're seeing. And that's the thing where a lot of our customers see most of the opportunities coming from.
Great, thank you, Seth. So just leading on to that, Sharif, I think in terms of what we're looking at around optimization of these systems and how you work in terms of projects, could you also give us some background on that, please?
Sure. So when we're working a lot in sub-Saharan Africa, there is often kind of poor and unstable grids. So the need for storage in those areas is particularly important, and the validation for solar is a stronger business case there. What we're finding is actually it's the management and the monitoring of the batteries and the storage is what there is a bit of a gap, where in stable grid countries that is kind of routinely done, but we've noticed that in a lot of African markets, that area is not fully developed. So we want to be able to be a data-driven business where we can generate live data on individual battery performance to optimize them and make sure that we can lower the lifetime cost of ownership of the actual assets. And this is something that is a challenge in itself because it's not something that it's not a very developed market. And a lot of people have a very strong knowledge of storage in a solar system. And because batteries often are the highest cost within a solar system holistically, that is the need to try and make sure that there is efficiency, that is operating in the most efficient way. So a bit about kind of what we do is we kind of use a mixture of hardware and software and on-site configurations through an app to quickly identify problems with batteries. And what can happen is one bad battery can often bring down the whole fleet if not corrected early. So really using data and we're moving into AI and kind of machine learning to really dictate when is the point in which a battery will start to kind of fail. So it's a very interesting space to be in. And what we're finding is now we have many live sites in Nigeria, like 50 live sites in Nigeria now. And very quickly we're identifying the problems with batteries, and with lead acid batteries particularly. Like they account for around 70% of the rechargeable battery energy storage market. And there is a big movement towards lithium and other technologies, but we want to make sure that it's accessible and the price is brought down, because even though over time the innovations will bring the price down, still it's a very high cost and inaccessible to many. So really the monitoring and the management of energy storage is really what we're trying to focus on and try to help, which will end up helping increase access to energy fundamentally.
Thanks, Sharif. So I think that a general theme that I'm picking up is the access to least cost storage technologies, either whether in the case of an LCOE or an OPEX cost over time in terms of the lifespan of the batteries. Perhaps, Rod, in terms of what you've experienced to date, and you've touched on this when we first spoke around a challenge in terms of a cost and in terms of lithium specifically. But are there any other challenges that you see with across technologies in the space? And then perhaps, you know, touch on the solutions that are out there in the market at the moment. And Rod, you just need to unmute yourself, please.
Yeah, sorry about that, Avesh. Yeah, one of the main challenges is to actually educate the market. There's so many new technologies coming into the storage area that even experienced site managers or engineers or energy managers, I don't say they're confused, but there's so much literature, so many pitches being made to the end users. And if we just take the mining industry as one example, so actually educating or having a balanced assessment, evaluation on your particular solution, and increasingly all of us in this space, we're part of delivering a hybrid solution. So it's not just one technology. That adds complexity, and then when you add geographical, real-world challenges with unstable grids, some very rough terrain, and climate variation factors. So it's contingent on all of us as an industry, on a CNI storage industry, to actually communicate our messages consistently and in a balanced manner.
Thanks, Rod. And on behalf of the SAISA, which is the South African Energy Storage Association, this is a problem which we've encountered over and over again. And part of that is what we're looking to do is, and we set up a committee around this, is to develop an energy storage handbook that is aimed not just at end users, but specifically industry experts, vendors, and engineering consultants, because the technologies that are coming online they're new technologies each and every day. And really what we're trying to see is, can we develop something that is relevant for markets on the continent? You mentioned things like unstable grids and other geographical constraints which may not be applicable in other areas. So we're definitely seeing that at the moment, and it's something we're working on. Savet, could I ask you to also share some of the challenges that you see in the market currently? Yeah,
for sure. It's actually the one that comes to mind first is the supply chain issues. And I know that this is not just a thing in solar, it's not just a thing in a feature in batteries, but over the past months in particular, we've had quite a lot of our customers describe the bottlenecks that they're experiencing with procurement. Now, over time, of course, that's something that should get resolved, but I think it's worth remembering that especially in the battery space, and especially now that kind of lithium ion is the de facto the de facto chemistry that's being used for most of these projects, you're relying on supply chains of some pretty specific minerals, and you have huge growth in the EV space that's taking up a lot of that supply, which means that then for projects that our customers are deploying across Africa, for example, it's often a bit more difficult to source those. So that's something I want to put out there, because I think it's just simply on a lot of people's minds. It's probably not something that we, can do much about here. But I think it does, maybe somewhat to Rob's point, also point to, well, let's get a little bit creative about how we approach this in terms of chemistry and other things that may be on our mind for the longer term. Maybe to touch on something that's a little bit closer to closer to our capabilities, and also very much reflecting on what Sharif was saying earlier about monitoring and management, is we have seen that with many systems that are deployed, because of a certain lack of oversight, let's call it a lack of monitoring, a lack of active monitoring of what's happening there, or a lack of ability to monitor what's happening at those sites, there is more significant degradation than the installers would have expected at the outset. And there is a risk that leads to a certain level of market spoilage, let's say over the coming years. And it has probably over the past years as well. And I think Sharif is probably even better positioned to talk about this than me. But people who have installed systems, they've been promised a certain lifetime and a certain level of performance over that lifetime, but that just hasn't materialized. So we, very specifically did a study of 15 CNI systems that one of our customers had installed in Nigeria, took a year of data and looked at degradation over that year of data, and together with the partners at a company called Accured based in Germany that specialize in battery health monitoring and analytics, we crunched that data and essentially discovered that for a couple of those systems, the level of degradation was actually far greater than what had been anticipated. And it was not something that the standard indicators on those batteries had caught. So I think there is a lot of opportunity there to do much more in that space, in the analytics space, in the monitoring space. Maybe this is a good time for me to hand over to Sharif, as I'm sure he's got a lot to say on that.
Yeah, sure. So you're right. There's definitely there is a lot of challenges on the continent, especially with the lack of understanding about battery performance. People expect their batteries to last a certain amount of time, but unfortunately, it's just not really hitting that time. Mostly, like people would say that it might be the manufacturing default, but most of the time it's from mismanagement in the field. And people don't have access to data and access to information on how their sites are performing. And this is a big gap. Like we've actually been installing in Nigeria earlier this year, and 9 out of 10 sites immediately flagged an issue. And actually, if that's not picked up early enough, what's going to happen is you're going to bring down your whole fleet. So you're going to have a big bill or having to replace all your batteries in one go, which in the CNI space is very costly. Like that means you're going to be using a lot more diesel on your generators, and the prices of diesel are going to be going up. And you're not going to get as much power from your batteries that you're needed. So I really think that the key focus needs to be on, okay, you have your system, you have your batteries, but you need to have that information just to check that everything is working holistically. And we're also moving more into energy monitoring as well, which is measuring the energy in and out of a lithium string, and measuring the efficiency of your generators. And I think having this information is very valuable because it gives more of an understanding on how much you can forward plan more about how much your batteries will last, and when you'll need to replace them. And it's really, the value is in the data. And so as technology develops, we can start using more AI and machine learning, which will then take this to another level. But really what the fundamental thing is to make the systems more affordable for installers, and to not have problems in the field where they don't know where the problems arise. So it's about developing that understanding, and it can be a challenge for sure in that market because it's an upfront cost. Monitoring is an upfront cost, but what we need to educate people on is actually the long-term savings, and actually getting people into more of a strategic mindset with their storage.
Thanks, Sharif. Thank you. So I think the things that were mentioned today is critical. The education of the market. We've seen that there are supply chain issues which we initially probably thought were transient, but have continued for a number of years, and we're certainly seeing that impacting a lot of the projects that we're involved in. But I'd like to go to now moving to the other side of the coin and really saying, so what are some of the success stories that we've seen in the last 5 years, either at each of your companies or in other applications that you see as a positive step towards the way storage is being viewed? So I think in terms of expectation, and 2, in terms of a use case. So right with that, could I direct that to you first, please?
Yeah, I'll talk in general terms rather than specific use cases or so I think where the successes have come from with the growth of hybrid solutions in the renewable sector, you now get many cases across many industries and across different markets, and particularly in Africa, whereby you're getting a higher penetration percentage for renewables. So I think that pendulum is definitely moving and will continue and always move in favour of renewables. So then that gives rise to getting closer to reliable, clean energy on a 24/7 basis, not on 16 hours, not on 8 hours, but on a more consistent 24/7 basis. So that gives rise to a more stable, grid or off-grid, microgrid operating scenario, and then that in turn gives rise to, as ESG, as government policy, zero carbon initiatives, as they take hold and get meaningful traction. We've got a platform on which to build, having more stable power environments, higher percentage penetration of renewables, and basically building a pathway across these hybrid solutions that we're all part of to coming up with a roadmap or a pathway to zero carbon, where start on a trial basis, then move into a phased rollout, which, depending on the size of the operation or the mining company, to take one example, such a roadmap might be a 5-year journey. So it might be in 2 or 3 or 4 phases over a extended period of time. You're on mute, Avesh.
It's my turn. the most commonly phrased phrase throughout the last 2 years, you're on mute. Eh? Svit, could I ask you to pick up on that, please, as well?
Yeah, I mean, if I was to think of success stories, I think across the market, the success story is the fact that there is just much wider deployment of storage. The business case around it has been solidified greatly, and the fact that these days, for any system where you're looking at installing diesel as backup or diesel as a tool that kind of gives you the flexibility, you can now, in most cases, switch to storage at minimum incremental cost. I think that's a huge benefit. And we've just seen across the portfolios that we work with, that kind of trend happening much more quickly. We've seen it happening at small scales where people with individual households and small C&I systems are also switching to storage. Avesh, one of the markets that we work in is South Africa, where you are, and that's just such a common thing these days for people to be installing not just solar but also storage systems. If we compare that to just a couple of years ago, it's a completely different picture. At the large scale, we're also seeing procurement of storage. I mean, there's large utility scale projects that are done now by quite a few different countries, and again, South Africa is leading in that in terms of national procurement of storage systems that allow the incorporation of the required levels of renewables and the required levels of backup into those national grids. And there are great trickle-down effects from that to the rest of the market, of course. And then lastly, recognizing the fact that across the market, people are looking at these systems that they're installing and thinking, okay, how do I get the most value out of that? How do I ensure sustainable, reliable operation over the expected lifetime, and recognizing the value of digital tools, the values of monitoring and management of those systems. And again, maybe at a household level, that's something that's still less commonly done, and there's still more education to be done. But if we look at CNI, and especially operators of portfolios of CNI systems, I think for them it's completely clear that you need to have a strong handle on what is happening across these portfolios. You need to be able to identify any issues and proactively tackle them, because otherwise, that business model just doesn't work. So that's a real positive sign that we're seeing as well as this market matures and people find ways to get the most value out of what they're installing.
Good, thanks, Vetch. Sharif, could I hand it over to you?
Sure. I think a big success story is people are starting to really see the benefits of solar and energy storage, and they're looking for solutions. So people are now actively looking for help in their business to make it more streamlined. And what I've noticed from doing early trials as well is very quickly, with very simple tools, you can actually get a lot of information. So by monitoring just a few parameters or by measuring just a few different areas of an energy system, you can actually get a lot of value, which gives a lot of optimism for me, because it means that we're moving towards a kind of simpler way of managing your system. So through monitoring as well, what we found is we can actually find diesel generator runtimes, just looking at battery discharge cycles, which can then help save diesel costs and kind of like analyze how much usage there. So it's pointing people in the right direction of what to kind of focus on, I think. And I just think that there's a lot of optimism in the market right now. And obviously, as it gets developed, more people will be kind of looking for energy storage solutions and looking for tools and simple, intuitive design. Like I know with AMP as well, it's very easy to use. You just use a mixture of very simple hardware and software to give a lot of information. And I think that's really where the success is going to lie.
Thank you very much, Sharif. I think that what we've seen in the market, specifically in the CNI space, is I use an example where we would be working with a client that's in the manufacturing industry, and they would be manufacturing plastic molds. And each time there's intermittent power, or as the term we use in South Africa, load shedding, when power is cut from the grid, that factory and all the machines that they're running effectively has an abnormal shutdown. And the financial implication and the cost is significant, because you have, I was looking at it a couple of weeks ago, there's 2,000 or 3,000 employees in that factory, and it takes another 8 to 12 hours to switch those machines back on. So when we talk about levelized cost, and we talk about at least cost option in terms of operating costs, what we're seeing certainly in South Africa is that the opportunity cost for not having reliable, stable power is significant, because the revenue that's lost in that one day, has a significant impact on those businesses. Something I'd like to touch on at this stage is, and this could really be anywhere in the continent. We've talked about projects in Nigeria and touched on things in South Africa, but really anywhere, East or West Africa. This relates to the regulatory environment. What we're seeing in South Africa is that it's still a very nascent application, and people are learning as we go along. Regulators, vendors, end users, and it's a mishmash of people learning. So with that, what follows on next is regulation. And so Rod, if I could ask you this question here is, what do you, in terms of an enabling environment for storage technology to boom, to thrive, what do you see on the continent, at least, that we need in terms of regulation, either we have or in place in certain countries, or that is not currently there for it really to provide a runway for this technology to thrive?
Okay, if I start by distinguishing between the public sector and the private sector, So for a early stage commercialization company such as 24/7 Solar, we clearly have a preference for targeting the private sector, because the sales cycles are typically significantly less shorter than the government sector. And then we break the private sector into there's various criteria that we would assess the private sector against. For the public sector, maybe for some of these countries, because there's so many new emerging technologies that are not well deployed, not well known in the market, maybe if some of these governments actually encourage the development of, economic development zones, whereby these technologies could be actually trialed, not on an exclusive basis, but on a collective industry basis, on renewables, focus on storage, whereby different providers of those technologies could actually establish a demonstration or a pilot plant or solution, and that would certainly accelerate the educational side of the solutions. Plus, seeing is believing. If you actually have tours, you encourage people to come and see not just one technology, but maybe you've got 10 different storage solution technologies, so which would allow an easier evaluation and gives confidence to to the industry and to the end users.
Thank you, Rod. Thank you. That gives us a good breakdown of the segments there. Savet, could I ask you to jump in, please?
Yeah, I mean, regulation from our perspective is going to be something that will play an increasingly important role. It's worth maybe reminding ourselves that where we've got to now in terms of deployments of both solar and storage across Africa has been pretty much without any help from regulation. I mean, of course, you have sort of VAT exemptions and things like that that are available in some places, but by and large, there hasn't been the either feed-in tariffs or other incentives across the continent that have benefited developers in, let's say, Europe or North America or other geographies. And in some sense, the expectation is that will continue to be, Africa as a continent will continue to be somewhere where you don't have that really favorable regulation. But the take-up is driven mostly by literally the need for reliable energy, the need for clean energy, that especially commercial and industrial customers are sort of taking into their own hands. Having said all that, we are seeing a lot of very promising movement across quite a few different markets. And one of the things I'd call out is that in South Africa, we're seeing, quite a significant drive towards increasing flexibility in energy markets, especially when it comes to, for example, feeding energy back into the grid, sometimes being paid for that by the utility. But sometimes not. Sometimes literally having the ability to feed that power and wheel it, so to speak, to another consumer on the grid. And we're actually involved in one of the first wheeling projects of that nature in South Africa, in the municipality of George, near Cape Town, where we have several commercial and industrial generators who are generating excess power, feeding that into the grid, and selling it to others who are connected to the same municipal grid. That then enables really interesting business models around what you can build in terms of a generation capacity. You can essentially oversize that because you will know that you can then have the ability to sell excess power to others on the grid. It allows others to then procure that power at a cost that is below the utility cost. Now, these are the kinds of enabling regulations that we are seeing more and more often. they're the kinds of things that don't really necessarily even need any government investment. So they're not subsidies as such. It's literally the utilities and the regulators saying, okay, we're going to allow private energy players on these grids to do more with what they're generating or consuming. And that's something that we're really excited about. We think that what being built up now in these pilot projects is going to prove the value in that and be a real enabling model for what can be done across the continent. And we've seen a lot of willpower to actually do more of that also in places like Nigeria, even which have traditionally not been sort of at the forefront of enabling regulation here.
Thank you, Seth. I think it's sitting in South Africa at the moment in Johannesburg. It's one of the things we're most excited about, because this will effectively enable a free trade in market for energy trading, and that's the first step in terms of that regulation. So, Sharif, would you like to add?
Yeah, so I definitely agree with what Svet was saying, and what we've noticed is in Nigeria particularly, there's a lot of young businesses, a lot of young people that are doing really amazing things, and they're doing that without government support. And so I think really what the regulation could be is for enabling them by the governments to basically continue to innovate in their own markets. I think that the private sector, so the public sector, doesn't really give that much for the innovation and the development of the market. And although they have declarations for a lot of rural villages and rural electrification, a lot of the great work is coming from within the cities, within the C&I space, that knowledge can then be fed rural. So I think that it's really about putting the power into the private sector and allowing people to innovate.
Thanks, Sharif. So I'm going to take the opportunity to touch on some of the questions that we have from our delegates. So the first question is from Era Hali. I hope I pronounced that correctly. And really the question is, are there any tools or software to plan and model? So this is a combination of a hybrid system with a PV and a battery energy storage system, as opposed to identifying issues after the fact. So I think the question there is, is there software which can be used from the onset, so prior to installation, to really in terms of modeling those inputs, and then during the continued performance of the plant? And I'm going to raise the question, and please just let me know who would like to respond to it.
Sounds like a question for Sharif, but yeah, it's all built around predictive analytical tools. So AI, ML, absolutely.
Yeah, I would agree. I think it starts with planning ahead and making sure that you have all the monitoring and management before you start, so that you can carefully plan ahead, and as it's going on, you can carefully see where the problems arise early. Because what we find is actually when you start putting on existing monitoring on existing systems, you'll always pick up problems if they're already in use in the field. But before installation, if you start from a new site, you can start afresh and really see the most cost-saving benefits.
Maybe to just jump in, I mean, directly to that question, the tool that I think most people in the market would be using is something like Homer, which is kind of in the de facto hybrid system monitoring tool for the past years. The caveat, and maybe also the second part of the question around performance and some of the issues that Sharif and Rob mentioned, is that of course you need to feed some parameters into your model. Some of these need to be performance and degradation parameters, and what people will often find is that you look at the battery spec sheet and you feed in those parameters. In reality, that's very rarely what you actually get as performance on the ground. So you probably have to build a level of a margin into that model that you would get from a tool like Homer when you're modeling out performance of a system over a number of years.
Thanks, Seth. So the next question is from John, and it's directed to you, Rod. So John says, you've mentioned that 24/7 solar solutions can be up to 90% less expensive than specifically lithium storage. Could you give some more background as to how that is possible?
Okay, the factors that drive that, point one is the storage medium. So our storage medium currently is silica sand. Previously it was ceramic pellets. So there's not much that comes cheaper than dirt, whether it's sand or whether it's ceramic pellets. Second point, extremely low O&M. Our turbines run on compressed ambient air, very few moving parts. They're not powered by steam, so no need for water. Many of these markets are subject to water scarcity, which has a higher cost. And water gives rise to rust, gives rise to various maintenance issues. So no steam, so no water, no steam, therefore lower O&M. So storage medium, number one, low O&M, which then that also contributes to a longer life of asset. So in the case of 24/7 solar, all of our component parts making up a battery storage system, or indeed the integration into a hybrid solution, they're all engineered to be at least 20 years.
Thank you, Rod. John, I hope that answers that question. There are a few questions, and one specifically from Vimar. It really relates to battery storage and across different technologies, whether it's lithium or vanadium or any other input and source. His point is that there's a perception that there's a threat of just around explosions and fires. And I think a general perception, if you had to speak to someone that's not in the industry, that's one of the things that it would raise from a safety perspective. So is there, and this may be more directed to Sharif or Savet, is there a way to detect and possibly suppress any of those type of situations prior to them happening, or anticipating what is happening in terms of the battery?
I think, well, if you're measuring things like temperature and certain parameters, you'll very quickly see if there's a battery or it's some kind of storage out of balance. So when you're analyzing the data and you see big skewed data and problems quickly, it's quite obvious that there might be something wrong, and that could potentially be a hazard. Specific like parameters to measure on fires and stuff, we haven't necessarily developed yet. This is something we have put a lot of focus into. But I think what would the beginning would be to monitor the batteries to see which, if any, are particularly acting out of sync, and whether there is a safety issue within that.
And maybe just to say that, the way we think about questions like that, essentially in three phases. You've got the design phase. You want at the outset to try and design a system that is not going to be susceptible to these things. You've got the prevention phase. So the way the system is operated, you want to put in place measures to prevent that. And then you've also got the monitoring phase that kind of goes on the side, which of course is a very valuable one. While the system is being operated, you want to make sure that you're keeping an eye on what's happening, and that's essentially what Sharif mentioned, and it's something that we've done quite a lot of work on also with our partners at the Cure, who have looked at a lot of battery data across many different use cases. Going back to the first one, one interesting development we're seeing is that there's quite a shift from lithium-ion to lithium-iron batteries. With the iron chemistry being much less susceptible to fires. It's got some disadvantages around energy density, but those are actually not very pressing when it comes to stationary storage, as we have in basically any hybrid energy system. So we are seeing that being sort of the increasingly dominant technology for stationary storage. And with that, actually, the risk of fires in stationary storage in the kinds of systems that we're talking about is actually a lot less than the already very low risk of fires and explosions that people are sort of have been exposed to in the EV world. So that's something that I think should give people a bit of an easier time sleeping at night.
Thank you for that, Svet. So just touching on what we spoke about earlier about the EV market and its appetite, or its insatiable appetite for stationary battery storage. Where do we see the future of energy storage? And I'm going to ask you to keep it relatively brief and in terms of the response, please.
Okay, the future will definitely include new and improved materials. Another trend will definitely be in longer duration. So no longer have a fixation on 12 hours or 16 hours or 20 hours. That will go into days and will go into weeks. So that's very much a future development as well. Economies of scale will be a third factor, which means that your unit costs will decline on both a CapEx basis and also a OpEx basis.
I would say, go ahead.
No, please.
Sorry, I was just going to say that I think the main thing would be the price point going down significantly, new technologies and developments entering the market across a range of technologies as well as new ones. And from a monitoring point of view, it's just improving the algorithms and being able to make predictive claims about when a battery will fail, so that you'll be able to basically lower the lifetime cost of ownership and therefore lower the reliance on generators and improve overall, make it more accessible and improve access to energy.
Yeah, from my side also calling out three main points. Firstly, a diversification in terms of battery chemistries, but also in line with that, a drive towards scale, as Rod was mentioning. So there are inevitably going to be some technologies where we're able to drive such enormous scale, as is happening with lithium ion now, for example. The costs are really plummeting and driving adoption. Secondly, we've got enabling regulation or more permissive regulation that really allows people to get the most out of the storage systems that they're being installed. And with that, better digital services to allow that value to be unlocked from storage, especially as we get these more complex energy flows, both within any given system and across that system in utilities and other players in the energy space.
Thank you very much. This was really a very fascinating panel, and enjoyed listening to your insights and your experience as well. With that, I think that we have reached our time, which is at 12:30. So, John, would you let us know?
Yes, this is perfect timing. Thank you so much, Avesh, for moderating this session and for respecting the allocated time slots. And also big thanks to your different panelists for sharing their insights and their experience from live projects. It was indeed a very interesting discussion to follow. And I'm sure there will be several follow-ups and questions from our listeners today. So don't be surprised if several people follow up with you and get in touch to get to know a bit more about your solutions and your experience from directly from projects. Thank you so much, everybody.